Hi, everybody. My name is Greg Tolentino, and I want to take a moment and thank all of you for joining us for the first PSCal user group and demonstration webinar. I know that a lot of us are working odd schedules and odd duty locations, so we all really appreciate you taking the time today to stop by and check out a little bit about PSCal and take a look at the demonstration. So I want to go ahead and get started sharing a PowerPoint presentation here for a little bit. The webinar will be a mix of a little bit of PowerPoint, a little bit of hands-on, and a little bit of demonstration. What we're going to go through today, there'll be a little bit of an introduction. Talk to you a little bit about TEGAM and about myself. We'll talk a little bit about the PSCal user group, what we hope to achieve with the PSCal user group. This is a new endeavor for TEGAM, and what we hope is that we will solicit good feedback from the community, from the user community, and get a better sense of what's important to you guys out in the field. So anyways, we'll talk a little bit about what we hope to achieve with the user groups. And then there'll be two demonstrations today. The first one is a really interesting feature of PSCal, not really a documented feature, and it's the result of one of the plugins that is in PSCal, but there is the capability to connect an external database to a PSCal report. So you can bring data in from an external database and add that data to your reports. So we'll walk through a very simple use case on connecting external databases. And what I hope is that that'll be a launch pad for further integration. And I'm interested to see what you all may come up with out there in the field. And then that one will take a few minutes. The second demonstration should be fairly quick. This one is really the result of some of the pain points that folks have felt in the field using PSCal. And so I wanted to take a moment and just do a quick walkthrough of how to calibrate low power RF sensors. Again, that one should only take a few minutes. We'll get a little video and we'll do that one live. Lastly, there's a new, I want to take a moment and introduce our new integration project, which is the PMX18CS. I think that that's a pretty interesting calibration system. And so we'll take a few minutes at the end and just introduce that to you guys. And of course, if you have questions at any point, feel free to use the Q&A feature in the webinar, and or you can always reach me after the webinar concludes. A lot of you, we've worked together with a lot of you already. Those of you who don't know me, my email address and phone number will be available at the end of the webinar. And finally, we'll wrap it up with some questions and answers. So to go ahead and get started, by way of introduction, for those of you who don't know TEGAM, leading manufacturer of RF power sensor calibration systems, and we've been doing this for over 30 years, starting back when we acquired the instrumentation division of Lucas Weinschel. That was in 1997. And from there, we built upon the technology that we acquired from Lucas Weinschel to put out into the market a whole new line of RF power standards, RF power meters. So you can see in 2003, wideband power standards, the models F and M1130s. Many of you have worked with those, especially anybody who has prior military experience. In 2008, came out the 1830A thermistor power meter, which is fairly ubiquitous in power sensor calibration, used with a lot in a lot of commercial and military laboratories. 2011, we pushed the frequency band a bit and got up to 50 gigahertz with the 1510, which is a terminating 50 gigahertz standard, and the 2510A, which is a feed through 50 gigahertz thermistor standard. The next items on the list are actually some of our high power calibration instrumentation. So in 2012, we had a model 1311 calorimeter. That one, I believe, is a 250 watt calorimeter. In 2015, we commercialized that package into the 1314 calorimeter, which is certainly a 250 watt calorimeter. And then shortly thereafter, we're followed by the 2601 and 2602 coupler-based transfer standards. And those standards are, they utilize our existing know-how on the 2505 and 1505, which many of you are probably familiar with, but enable us to measure, to bump up the power, measure higher powers. And then there's a couple things not on the list, just pushing the power limits up. So we have 5K and 10K watt calorimeters as well that are in the pipeline and being worked on. So again, this isn't, I don't want to talk too much about high power, but I do want to let you guys know that that stuff's out there. And if you want to talk further about it, feel free to give us a call anytime. And then in 2017, we acquired PSCal, Power Sensor Calibration Automation Software, which is, of course, what we're talking about today and what we will be demonstrating while we're here. A little bit about me for those of you whom I have not had the chance to meet yet. 8 years in the Air Force as a PMEL technician. And while I was in, I finished up my Associates of Applied Science and Electronics Technology. And then after my military career, I went and spent some time in college for undergraduate and graduate degrees in business. I came to TEGAM in 2013 and been here ever since, and worked in several roles while I was here. I was the applications engineer for a while for bond meters, amplifiers, and thermometry. Moved into the thermometry product manager role, and then 2.5 years ago, moved into the RF product manager and applications engineer role. So right now I'm covering both things. If you have a question or want to walk through a particular feature in PSCal, I'm probably the one that, that will help you do that. So the PSCal user group overview and goals. I wanted to take a moment and talk about this since this is our first foray into a user group. And so I wanted to just kind of lay out what we're hoping to achieve. And of course, after this wraps up, as always, I invite you guys to email or call if there are other things that you would like to see or things that you think would be critical to go over in a forum like this. So what we're hoping to achieve, though, is to have an opportunity to connect with the PSCal user community. That's first and foremost. I talk with a lot of you folks that are in the field quite often, but we don't get to talk with everybody. And so we're hoping that by putting out these user group meetings, we hope that we'll foster good communication between the field and us about PSCal. And that not only includes what's happening today in PSCal, but what might be happening tomorrow or 6 months from now or a year from now. We also hope to use it as an avenue for timely communication of PSCal news and updates as new features are added, new releases are published, new documentation, whatnot. We'll use this as a forum to announce that, as well as on our website and email communication. We, over the course of our work in PSCal, of course, we hear a lot from users and what's working well and what isn't working well in the field. And so this user group is also an opportunity to demonstrate some calibration tasks that maybe have been problematic, maybe are just a lot of people are trying to perform them. And so a nice overview or review would be really helpful. But also, and interestingly, we get a lot of good feedback from users who are trying to do creative, sort of quote unquote non-supported features of PSCal. And the first one today is one of those things. One of our users in the field wanted to be able to connect an external database to their PSCal reports. We worked together on that, figured out a way to do it. And so I thought that that would be a good thing to share with the community at large. So we hope to use this forum as an opportunity to do that. And of course, lastly, gathering user feedback. And again, that's, you know, we're interested in how it's working for you today, and we're also interested in what you're looking for in the future. as new sensors are released, new sensor technology is released, the most recent one being USB sensors, and adding those, adding that capability to PSCal. So things like that, that feedback I think is invaluable from the field. So hopefully this forum creates a good channel of communication for that. I also want to take a moment, and we have a very diverse audience with us today. Some of you have used PSCal for years, and I think some other folks may not be users at all, may not have had a chance to work with PSCal. So I just want to say, first of all, thank you to all of you for attending, but second of all, these particular demonstrations may have more immediate value to those who are current PSCal users, people who are familiar with the software and looking to do some more advanced things. However, I don't want that to discourage any of the folks who are here just trying to get a sense of PSCal, to get the flavor of PSCal, if you will. While we're doing two very discrete tasks as demonstrations today, it'll still give you a nice overview of what PSCal does, and you can kind of see it work a little bit. And of course, we're always here for you after the webinar if you have more questions. So the first demonstration, this is going to be connecting an external database to a PSCal report. Again, I want to thank our users in the field for putting this idea out there, that this is a thing they wanted to achieve, and I appreciate their efforts working with us and sharing their knowledge to be able to put this process together. So the process overview, we'll run through this real quickly, and then we will actually perform the task so that you'll get to see it step by step. But a little bit of background is important first. PSCal actually uses a plugin for reports. That plugin is by a company called Grape City, and it's called Active Reports. Those of you who've worked with like Crystal reports in the past, probably pretty familiar with this, this approach. And PSCal uses Active Reports in a similar way that many programs would use Crystal reports. Active Reports is very powerful, and it has its own user base and help guides and frequently asked questions and things like that. And so I would absolutely encourage everybody that has interest in making their reports more robust to go check out the Active Reports pages. And when we send out the link for this webinar, I'll include some links to the Grape City Active Reports help user guides. So with that background in mind, we're going to use that Active Reports plugin in PSCal to connect to an external database. The overview of the process, just sort of an outline of the steps we'll be taking. First of all, you have to have a database, some sort of external database. I have one that we've already made, and it's just a simple Microsoft Access database. And all it does is hold some of our standards and the cal due dates for those standards. So that's the information that we're going to input into a report today. Much like working in anyone who has any familiarity with programming is probably put text boxes and label fields onto a form. These Active Reports forms are no different. They work the same way. So all of the data that you see in the red square there is from a database, and those are all text boxes and labels. The text boxes actually contain the database data, and the labels, of course, are column headers and the standards used header up there. We'll create a data connector inside the report. So the report will always have that data connector and always be connected to the database. There's also an optional feature, which I thought was pretty neat, so I wanted to include it here, and that is to add a user input dialog. So in this particular case, and we'll see this when we look at the database, in this particular case, there are two tables in this database. One is for type N calibrations, and the other one is for 3.5 millimeter calibrations. What you see on the screen there is the 3.5 data set. So the user input dialog is really helpful because that allows the technician in the moment of calibration to say, or in the moment of generating the report to say, I want to use the 3.5 millimeter table, or conversely, I want to use the type N table. And we'll link the report fields to the database table and fields, and we'll walk through that. And of course, add labels and organize report controls as desired. You have a lot of flexibility in how you design these reports, and you can set them up to do what you need to do for your particular work site. So we will go ahead and move into a demonstration of how to make this work. So you can see I've switched screens here, and we are inside PSCal right now. We don't have any template loaded or anything like that, and we don't need to for this particular issue. I also want to take a moment and show you that in the PSCal root directory, I have an MDB file, and that's a Microsoft Access database. And we'll go ahead and load that up and just show you real quick what we're working with. I think that context will help as we walk through the process of putting this into our form. So we got two tables here. We got a 3.5, which just has 6 different pieces of equipment listed, along with cal due dates. I added in some unique IDs here that really are meant to identify which table they're coming from, so that when we get to the end and I show you how it works, you can see that the different tables are working. And then this is the type N field table. So that's the database that we'll be working with. In PSCal, to edit a report, you first go to Tools, and actually I'm going to turn on annotation here. I hope that this will be easier for folks to see. Move that out of the way. So you first go to Tools, and you go to Edit Report. And you'll see that a new window is opened, and this is the Report Editor window. So this is tied into PSCal, but it's actually the plugin. This is the Active Reports plugin. In the Report Editor, I have to tell it which report I want to edit. So we'll go to File, Open. And in your PSCal root directory is a Reports folder. And inside of that Reports folder are some report headers, a whole bunch of sub-reports. Different sub-reports are used on different sensors. It depends on what test you run. And there's also sensor labels. So for the older style 848X sensors where you print out a label and stick it to the body, those reports are in here as well. So you could use this report editor as you need to edit any of the reports that are available in PSCal. What we're going to do, though, is we're going to focus on the report header today. It's just the one that I'm choosing for demonstration purposes. I highly recommend, before starting to edit a report, I highly recommend doing a backup. So we're going to go ahead and do that. You can see I've already got one, but I'm going to make another one. So we'll copy that, and we will paste it. And now we got a copy. I'm going to rename that. So I named that Backup 02. And that way I have that sitting there just in the event that I mess something up and it doesn't work. So for us, we're going to work on this report header, and I will go ahead and open that. And now you can see that just that piece of the report, and those of you who have generated PSCal reports before have seen these headers, and you've probably edited these headers a little bit. So I'm just working in the header file right now, and we're going to go ahead and make some changes here to prepare for connecting to the data source. So the first thing I do, I'm going to right click in this detail, and I'm going to add a group header and footer. In any report, in active reports, you can have multiple group headers and footers, and we're going to need 2 of them for this process. So I'm going to start with a group header, and this is primarily because I need to use this detail section. So I'm going to move everything that's in the detail. I'm going to move that up and put that in that first group header. And you can see I have a detail section down here, but I'm not quite ready yet to work with that. So the detail section is always going to hold your data, and I still need another header to put my column headers in. So I'm going to insert another group header, and now I have a group header 2. And now I can get started adding my adding my labels and text boxes, and then connecting to the data source. So the first thing that we need to do is we need to tell the report where is the data that we want to add to this report. And we do that by clicking on the detail. And you can see that there's a blank connection string box here, but fortunately there's a little wizard that will help you build that connection string. Here in the data link properties, I clicked build and it opened up data link properties. Inside of there, you have a whole bunch of different methods of connecting to a data source. For our particular data source, we're going to use the Microsoft Jet driver. So I'll go ahead and select that. That's actually because it's a Microsoft Access database. If you're using a different type of database, it may be a different type of connector, and you'll have to do some research on the side for which one would be the right one. So we'll connect to the Microsoft Jet provider, and then now the wizard's asking to enter the database name. So we're going to go ahead and browse to that. And if you remember, I had that in standards. So we'll just click that and click open. Username is fine, and there's a blank password for this one, so we're good. I'm going to go ahead and test connection and make sure that works. And the software tells me that the connection succeeded. So that's good. We're on the right track. The query can be a little bit more challenging, and we're going to use a very specific query that I know works for this database, but this is where the active reports user guides are incredibly helpful. So the query that we're going to go ahead and add today uses a particular syntax that will allow for user input to select which table they want to use. So just briefly, I'll talk to you about the syntax that I'm using here. We open up with the sideways caret and then a %sign. Those are syntax pieces that are particular to active reports. We tell it we're going to work with a table. This next string that I'm typing in is just going to be the user prompt title. And we'll use another bar there. They use bars to separate the various pieces of the string. So 3_5 is the name of the first table. Type N is the name of the second table. And then there's true, which determines how it searches for those tables. And we'll close it out with the % and the right-facing caret. So this is our connection string and our query for this database. So we'll go ahead and click OK. And now we need to add some controls so that we can see what's actually happening. So for purposes of the demonstration, I'm only going to use two. We'll use unique ID as the first one, and you can see I'm grabbing a label and I'm moving the label into the header section. That's important. So the first one will be the unique ID. The second one will be date, only cal due date, only because I want to have an opportunity to show you how to format the dates as well. So cal due date, and we will move this this header up a bit, give us a bit more room in the detail. The important piece is that the detail is the repeating section of the report. So if you have multiple rows in your database, multiple records, all of those records will be displayed in the detail. If you were to move the group header, the labels down into the detail, they would be repeated as well for each row in the database. So that's why it's important to have the group header followed by the detail. So we'll put one text box in for the unique ID. We'll add another text box for the cal due date. Now we have to tell active reports, we have to tell it how to connect to the data. You can see over on the right side of the screen, you have a tree that may be familiar to some of you that shows the different sections of the form, as well as some of the different controls. You got my text box 1 and text box 2, along with the labels there. The important part, though, are fields. This happened by virtue of the connection string that we just established in the last step. And here you can see that under fields, bound, we have all of the fields that are available in the database. So, so that's good. We know that we successfully made our connection to the database. So let's tell this text box what we want it to display. Select the text box, come over to the right and look at the properties. Underneath data is data field. And if you pull that down, again, you can see all of those bound fields that we just looked at, and we're going to add unique ID to that one. And that's it. That's connected now to that database, to the unique ID field. We're going to do a similar action for the cal due date. So now we've connected that to the cal due date. Unfortunately, right now, it's going to give you a full date string, which includes date and time. So we don't want that. That's probably not ideal for a calibration certificate. So we can edit that. We can change that. I'm going to go to output format, and I'll click on the little 3 dots to the right there. I get a dialog box that asks me how I want to format the data that's in that box. I want to format it as a date, and for simplicity, we will use a nice clear date format there. So I chose that one. You do have a custom as well, and so if you want to define your own date format, you can do that there. And so we'll click OK. And that is it. We've connected this database to the report. We should probably test it and make sure it works. Down at the bottom left, you have 3 different environments you can work in. We're in the designer. We're going to go ahead and change that to preview. And you can see over here on the left is the user prompt that's asking which table do you want to view data from. So we want the 3.5. It'll do a preview. And then, of course, you can see that we have the unique IDs from the 3.5 millimeter Microsoft Access database table. And we have the cal due dates, and the cal due dates are formatted just like we told them to format. If we come up to the user prompt and we type in type N and view report, we get a similar report, but this time it's pulling from the type N data table. And so that's it. We've created this report. We'll go ahead and we will save it. And now I can close the report editor now that it's saved. We'll make sure just to be sure. So we'll go ahead and close that. And I want to show you what the finished report looks like. But before we do that, I'm going to switch to a report that I made prior to the webinar that shows you a full finished product. So I'll come into reports, and this one is the report we just edited. I'm going to change that to user group. And this one marked as data source. This is the report that I made prior to the webinar. So we'll rename that. And now that's our primary header. Just as an aside, PSCal looks for specific report names. So you can back up reports. You can have multiple versions of reports. All you have to do is rename them, and when you need a particular one, rename it to, in this case, report header. So now that we got that set up, I'm going to pull up a cal results file. This is the template actually that we're going to use in the next demonstration. So we get the user prompt. The box is formatted a little bit wonky. We'll click OK. And here you can see this is a finished report where I have all of the data fields that I need on my calibration cert for standards used. I did a little bit of formatting here by putting some italics on the labels to identify those as column headers. And then, of course, you can see all of the data, and this pulled the 3.5 table. So that wraps up the demonstration on connecting an external database or data source to a PSCal report. There's a couple key points that I think are worth going through, and we'll try to do those fairly quickly. Important notes: always back up your existing reports before editing a new report or creating a new report. One of the things that I often recommend to folks, especially when I'm on site, helping them with their initial installation and system commissioning, often what I'll have them do is back up the entire reports folder. That's a safe way to make sure you have a backup of every report in there before you get into the report, before you get into customizing various reports. Make sure you use the appropriate connection string for your particular data source. Different data sources will have different connection string requirements. So make sure you research that and choose the correct the correct data connection string for your data source. Add a group header section for your labels. Remember, in the group header, those controls are not repeated on the form, and you can see those. You can see those right here. Standards used, and all of these model, unique ID, serial number, cal, do, and description. All of those are in the group header, therefore they don't repeat. And then text boxes are used in the detail section of the report. Those are the ones that repeat. So that's all of these guys here. All of those will repeat based on however many records you have in your data source. And when you get stuck, or if you want to try to build upon this and do new and creative things with these PSCal reports, by all means, get on the Grape City Active Reports website, find their user guide, their help forums. They have really robust help forums, and look up what you want to do. Chances are you'll find a way to do it. And if you want to chat about that or talk about that, let me know, and we'll see what we can do to help. So now we're going to move into calibrating low power RF sensors. This is only going to be a few minutes. There are a couple prompts in PSCal that have led to a little bit of confusion. So I just want to take a moment and walk through some of those prompts. The process overview, just so that we all have good context. In order to calibrate a low power sensor, these are primarily the D model sensors, Delta model sensors, so 848X Deltas. They come with a reference attenuator, and that reference attenuator is only intended to be used at 50 megahertz, which we'll see in a moment here where we do the demonstration. So from a calibration perspective, it's important then that the lab has a calibrated broadband attenuator, generally in the 20 to 30 dB range, to keep it in the sweet spot of a 2505, for instance, a TEGAM 2505 RF standard. So generally 20 to 30 dB attenuator. That attenuator should be calibrated, and you should have data available for that attenuator, data that can be imported into PSCal. For our demonstration today, we're going to assume that that's done, but I'll show you that point when we get there. Import the attenuator data into PSCal. There'll be a point, and the picture to the right shows this prompt. There'll be a point where PSCal asks the user, it says, does the bolometer data, so the TEGAM 2505 in this case, does the data that you used for that bolometer, does it include attenuator data? And the prompt, we're going to reword this so that it's a bit more clear, but I did want to take this opportunity to show you how to navigate through that prompt. So what it's really asking is was the attenuator that's in the top bullet there, the calibrated attenuator, was that calibrated with the bolometer? And therefore, does the bolometer data include that attenuator? For a TEGAM 2505 that was calibrated by TEGAM, so in our case, that answer is always going to be no. And so selecting no is important to PSCal because that prompts PSCal to then say, oh, okay, I don't have the attenuator data, so now I need to ask the user to load the attenuator data. That's the key step in doing these. We're going to run through it real quick, and you'll see that prompt when we get there. Of course, these D model sensors come with their 50 megahertz reference attenuators. That is to be used only for the reference and not for the calibration. They have a really significant drop off as soon as they get, just maybe up around 1 gigahertz or 2 gigahertz, they drop off really substantially. So you won't get a good calibration if you try to use those. And then use the calibrated standard attenuator for the calibration. So I'm going to switch up a bit here. We're going to switch back to PSCal, and I'm going to close those. And we're going to load a template that I made before the webinar here. This is the same one we just looked at for the reports. This is for an 8481D, and I need to do a bit of a mea culpa before we get started. We generally have an 8481D floating around the building. It turns out it's out for calibration. So I am using an 8485 Delta, but we're going to pretend it's an 8481 Delta for purposes of this demonstration. So I'm also going to share some video here. And those of you who may have not been part of a Zoom webinar before, I believe as users, you have a lot of control over how that video is presented to you. So you can right click on it or mouse over it, and you should get some options, and you can move things around if you feel the need to switch, like to swap the video with the PSCal screen. So please feel free to do that if you like. So I've created this template prior to getting started on the webinar. We're going to go ahead and just go straight into Cal Factor. I deleted out most of the frequencies for purposes of this demo. I just want to show the process and how to get this calibration started. So you can see in the video, I have an E4418 Bravo and a TEGAM 1830A along with a TEGAM 2505A. That's all the test equipment we'll need. The generator is sitting down below. So that's the equipment that we'll be using for this test. I'm going to go ahead and I'm going to start by configuring station, and then we're going to take a look at some of the user prompts. So this first one is fairly basic. It just tells you what equipment you need to get started with the calibration. So we've done that. I've already set up my station, and I've also already verified that my addressing is correct. So we'll click continue. It's going to go through a process here and reset some things on the station. And we had something go to sleep on us. That was your presenter's fault. I had turned off the generator because the fan was very loud. So I'm going to turn the generator back on, let that get booted up. And we'll configure station again. PSCal is going through and resetting some of the equipment. You might be able to see that in the video to the right. Shortly, it's going to ask me for the bolometer data file. This is for the TEGAM 2505. So once I click continue, PSCal is going to say, point me to the data for that particular 2505. So this is the calibration data for this one. I'm going to go ahead and click that and click open. And then there's a couple more connections. This prompt simply tells the user to make sure that the 1830 right here is connected to the 2505 and that they've had sufficient warm-up time together. These have been warming up all day, so we should be reasonably good to go. Click continue. And this is the prompt that has caused some confusion in the field. So this is why I really wanted to take a moment and talk about. This particular prompt is the one that's asking, the data that I just loaded for the bolometer, does that data include the attenuator? And again, for a TEGAM 2505 that's calibrated here at our factory, that answer is always going to be no. Our data does not include the attenuator. You have to load the attenuator data separately. So we're going to go ahead and click no. And PSCal then moves right into to a dialog asking essentially, okay, go ahead and load your attenuator file. So I have my attenuator file already here in my PSCal standards folder, and I'll click open. PSCal says thank you and moves on to the next stage. So what this is saying is go ahead and connect the attenuator to the TEGAM 2505. And that's okay because we're going to use the reference attenuator to zero the sensor, and then we'll disconnect from the reference attenuator and connect to the calibrated standard attenuator for the actual calibration. So I made that connection. And PSCal says, great, and we're ready to go. We'll go ahead and start the test. It asks me if I want to zero and calibrate the device under test power sensor. We'll go ahead and do that for illustration purposes here. And click yes. The first thing it says is to disconnect the power sensor from any RF source. We've done that. There's nothing connected to the power sensor right now. Click continue. And PSCal, as you can see here, is doing a zeroing routine. And once this finishes, now PSCal will ask us to connect our 8481D to the power reference output of the power meter. I'm going to go ahead and connect the reference attenuator. I can get it seated. There we go. So I've connected the reference attenuator. We're also using a reference adapter because this is an 8485 that we're pretending is an 8481. Make that connection, and we'll say tell PSCal to continue. And now you can see on the screen, PSCal is calibrating our device under test sensor. Once it's finished with that, it'll ask us to disconnect from the power meter, from the power reference output. And now we're going to connect to the standard calibrated attenuator on the TEGAM 2505. So we'll make that connection. And I didn't bring my torque wrenches with me today, but typically we would torque those down if we were doing a production calibration. So I've made that connection. We'll click continue. PSCal is going to start its calibration process. I believe there'll be one more user prompt. So we'll wait here for a moment while it gets going. And I just want to remind everybody, please don't hesitate to ask questions if you have questions. And we'll do our best to answer those. I'm running just a little bit long, so we're going to try to wrap this piece up and sort of zip through the next small section, and then we'll answer a few questions if we have time. And I would encourage folks, even if we're going to run out of time, I'd encourage folks to ask questions anyways. I'll get that list of questions and I'll reach out to you after the webinar in the next day or two. So this is the last user prompt. This is just connecting the RF output. Click continue. And I apparently made an error. Zeroing is working correctly. Zeroing the RF bridge. So we had a question while we're waiting on this. We did have a question about whether PSCal allows the user to configure their own test plans, frequency lists, test levels, etc. The answer to that question is yes, absolutely. PSCal does allow you to do that, and you have, I'm sorry, I was watching the test there. PSCal does allow you to do that. You can edit frequency lists like I did here for this particular template, and you can edit your test levels via the parameters. You can, of course, edit the equipment that you're using. There's a lot of flexibility that PSCal allows you. There's also, and in a future webinar, we can go through template building. template, when you build your templates, there are a lot of different techniques that you can choose from as well. So there's a lot of flexibility offered here with PSCal. So I hope that that answered your question. Please let me know if you want to follow up on that. I want to take a moment and just introduce the PMX 18-CS. This is a new system that we've just put together, and we'll be getting this up on the website relatively soon and let you guys check it out a little bit more and read in more detail. This is just a quick overview of what's out there. It's an 18 gigahertz calibration system that includes a TEGAM 1830, TEGAM 2505, and you see a small footprint EXG generator there, and a headless VNA, a couple drawers for accessories, and a laptop, and of course the power strip. The idea of putting this together is a nice compact system that out of the box will do what you need to do. All of the equipment is already configured to work with PSCal right out of the box, so you can pretty much plug this in, let it warm up, and calibrate power sensors. So it's ready to work. It comes with the TEGAM 2505, so primary standards lab accuracy levels in a compact system like this. Fully automated. It comes with PSCal, and PSCal or all the equipment is already configured and designed to work with PSCal. It'll come installed on the laptop that's included with the system, and will fire up as soon as you turn everything on, and you'll be calibrating sensors right away. It's configured. It was important to us to build a system that was relatively compact. So this is in a 22-inch tall rack. It can be used on a bench or on a cart. It's a two-man lift and can be loaded into a van for on-site cals. You see the second bullet there. There is an option to purchase this in a ruggedized rack case. So if you do a lot of mobile on-site things, if it goes into a mobile cal lab situation, especially for DoD requirements and things like that, it can be purchased in a ruggedized case as well. So again, this is just a quick overview of the system. It uses a lot of the equipment you're already familiar with, but puts them together in a way that's easy to get up and running. And just a quick, if you want to take a look at some of the different system components, the 2505 and 1830 from TEGAM, of course, it comes with PSCal, the Keysight EXG generator, and the Keysight P5000 series streamline vector network analyzer, which is a key piece in keeping the system compact. It's worked really well in our work here with it. And then some additional components. That the idea was to give you everything that you need to calibrate any sensor. So you get your attenuator. We provide torque wrenches with the system, the VNA cal kits, transport case for getting your 2505 calibrated, power supplies, cabinets, label printer, all of those types of things. So that about wraps it up. I apologize for the snafu on the PSCal. I got to look in and see what happened with that cable. I believe that's what it is anyways, but otherwise, hopefully that was really valuable for you folks, especially the external data sources. There's a lot that you can do with that. Actually, just last week, I had another customer ask if they could perform math in one of those reports. They simply wanted to add, here's my cal due date, and I want to add 1 year for or here's my calibration date, I want to add 1 year for a cal due date. And we've worked out how to do that as well. That'll be coming up, and we'll release a little blog or something that explains how to do that. But there's a lot of creative things you can do there. I hope everyone has a chance to play around with that and finds good ways to use it. we had a couple questions. We still got just a few minutes before we wrap up. So we had a question explaining zero and cal, the device under test sensor. When should you do it and when should you not do it? That's a fantastic question, and I've been in calibration for 20 plus years now, and it was a fantastic question when I started as well. For sensors like an 848X or something like that, those sensors are relative, and so you're not really comparing them to an absolute power level. You're comparing everything to the 50 megahertz reference, and that's the key piece there. So calibrating it to the 50 megahertz reference out of the meter isn't entirely important. What's really important is how do all the cal factors compare to the 50 megahertz that you measured in the calibration, in the actual calibration. That being said, it certainly doesn't hurt to do the zero, and you can always do that. I think the real question comes if, when you're considering your uncertainty budget, do you need to include the reference power output from the device under test power meter as part of your uncertainty budget? And that's what really leads to these questions. I will say that our goal with PSCal is to actually take a different approach with it, and this will not be in the next release, maybe the release after. Our approach is going to be to use actually the 2505 as your 50 megahertz reference. So as part of the calibration, the 50 megahertz reference will be performed. What we hope is, first of all, it helps answer this question: do I need to do this disconnect and connect to the device under test power meter power reference? And the answer then will be no, because you're doing it on the TEGAM 2505. The other big advantage with that approach is it minimizes the connects and disconnects for the user. So it makes the software a little bit more set it, get it going, and walk away. So that's a longer term goal for PSCal. We'd like to change that approach. So hopefully that answers that question. We got a couple more, but we're about ready to, we're gonna have to go ahead and wrap up. The folks who, I got two more questions that both of them require fairly lengthy responses. I'm gonna go ahead and try to put those together outside of the webinar and get back with those folks. Both of them are very good questions though, so I'll throw them up as a blog on our website so that everybody can see the answers. I think that'll be important. Thank you all very much for attending. I really appreciate it. I hope that you all learned something today. Thank you so much, and we'll let you know when it's time to do another one of these. I hope to see you all again. Thank you so much.